Hello everyone, how are you doing? I hope you are doing well. Welcome to this video. This is the video part number 5 from the test-driven development video series, and if you don't watch the video part number 4, you should watch it at first and then watch this video. Okay, what's on the agenda in this video? Today we are going to complete the Soundex class implementation through TDD. But before that, check out the session 5 branch. Open up the Visual Studio Code and on a status bar, click on branch button and click session 5 branch. Alright, last session we have coded something that does not completely meet the Soundex algorithm. We have implemented a function which is called encode, and it returns whatever it gets as input. And the last part of rule number 4 says that, let me show you the Soundex algorithm rules. The last part of rule number 4 says that we must fill in zeros until there are 3 numbers. And it means rules number 4 contradicts what we have already coded. Right now we have 2 jobs. The first one, we should write a new test case that describes the new behavior, and the second one is change our existing test to ensure it meets the specification. Okay, let's implement the new test case. Test f macro, Soundex encoding, test fixture, and test case name. Soundex encoding pads with zeros to ensure 3 digits. Should create an object from Soundex class and call the encode function with new input, and finally we should assert the result. Encoding should equal matcher with this. Alright, maybe you ask, why didn't we read the Soundex rules more carefully and write this first? Good question. Indeed, we weren't careful, and a strength of TDD is its ability to let you move forward in the face of incomplete information, and in its ability to let you correct earlier choices as new information arises, and it's really amazing. The new test case creates its own Soundex instance, and I should mention that every test case we add is independent. We don't use the outcome of one test as a precondition for running another, and each test must set up its own context. Alright, let's run the test case to make sure it failed. Alright, it's failed, and at this point the failing test shows that encode returns the string I instead of I000. Alright, the next step, get it to pass. Getting it to pass is really straightforward. We can just concat the string with 3 0. Alright, let's run test case again. Alright, at this point you can see the new test case is passed, but the first test case we wrote now failed. What's wrong? Alright, it's very obvious. because the behavior this test case describes does not match the specification. I mean the Soundex algorithm rules, and we should fix it. Okay, we should fix this test case. Actually, we should fix the expectation at the end of test case. Now let's run the test cases again. Alright, now all of the test cases are passed. When you have done test driving, you will know that the tests correctly describe how your system works as long as they pass. They provide examples that can read easier than a specification if they crafted well. Now we have two tests that perform the same steps, but the data differs slightly, and that's okay. Each test now discretely documents one piece of behavior. We not only want to make sure the system works as expected, in fact we want everyone to understand its complete set of intended behaviors. Alright, now it's time for refactoring. Take a look at the code and also test cases. The statement in code isn't that much clear. I think we should extract it to another method with an intention revealing name. I'm going to implement another function. It returns a string and its name is 0path. It gets a string. I'm gonna move this function to this point, and now I can call this function at this point. Alright, run the test cases again. We are done. We should also refactor test cases. Alright. Both test cases have the same line to create a Soundex instance. We are not happy with this kind of trivial duplication. It's common for related tests to need common code, and I told you in the last sessions, Google Mock lets us define a fixture class in which we can declare functions and member data for a related set of tests. And in these test cases, we also declared a test fixture, which is called Soundex encoding. Okay. We can move this duplicate line of code to this point. Alright, let me run the test cases again. Alright, let me tell you something about the test fixture. Google Mock instantiates the fixture class once per test. It means before Google Mock executes this test case, I mean retains sole letter or one letter word, it creates a Soundex encoding instance, and before it executes this test case, I mean second test case, pads with zeros to ensure 3 digits, it creates a separate Soundex encoding instance. And getting rid of the duplicate Soundex declaration does at least a couple things. The first one is it increases the abstraction level on our test. We now see only 2 lines in each test, which allows us to focus on what's relevant. We don't see the irrelevant detail of how the Soundex object gets constructed. And also, it can reduce future maintenance efforts. Imagine we have to change how we construct Soundex object. Maybe we need to specify language as an argument. Moving Soundex construction into the fixture, at this point, means we make our change in only one place rather than making the change across several test cases. All right, what else we can do? We can reduce each test to a single line without losing any readability. We can move this part to this point. And also we can do the same for the second test case. Alright, let's run test cases again. Alright, all of the test cases are passed. I think we can also move the Soundex class to its own header file. Let's create a header file which is called Soundex and move the Soundex class to its header file. And include it here, include Soundex. Run the test cases again. A single file was helpful for just a short while. We will also decide to create an implementation file, CPP file or source file, when we are done in the future. For our next test case, we tackle rule number 2. Alright, rule number 2. Replace consonants with digits after the first letter. A look at the replacement table reveals that the letter B corresponds to digit 1. Alright, let's test write it. Write a new test case. Test F macro Soundex encoding replaces consonants with appropriate digits, and we can copy the previous assertion and pass it a new input. We can pass it A, B, and we expect A 1 and 2 0 path. As with most tests we will write, there might be infinite ways to code a solution. Technically, our only job is to make the test pass at first. Alright, let's run the test case to ensure it's failed. Alright, it's failed. Let's implement it. You could provide a very easy solution to pass all test cases. We could write something like this: if var equal to AB, and we could return A1 and 2 0 path. think we could change this variable name to void. Okay, let's do it. It's more readable. I think it's not that much generalized solution. Do you know what I mean? Let's run the test cases again to make sure it's passed. It's passed, but it's not a good way. You know, the implementation that we seek is one that generalizes our solution, but does not overgeneralize it to support additional concerns, and doesn't introduce code that duplicates concepts already coded. This code does not move toward a more generalized solution for the concern of replacing consonants with appropriate digit. It also introduces a duplicate construct. You know, the duplication is here. We do the 0 path at this point and also in this function. Alright. We need a more generalized approach to do that. Let's do it. I'm going to remove this part and I'm going to get the substring through substr function. I'm going to get the first letter and then I'm going to compare the length of void with 1, and if it's more than 1, concat it with letter 1. Alright, let's run test cases again. Sorry, what's wrong? I misspelled this variable. Let's run the test cases again. Alright. Our new test case is not passed because the padding logic is insufficient. Alright. We should update the padding logic to consider the length of the encoded string. Alright, let's update it. I'm gonna declare a new variable, zeros needed, and alright, what is this? This is the maximum length of our void. I mean the encoded void. And also I'm gonna change this variable name to void. I think it's more readable. And the final one. Alright. And finally we can remove this part and generate this zero padding through std string constructor. This is one of the string constructor that generates a string of this char. Alright, let's run the test cases again. Alright, what happened? The new test cases pass. Am I right? No, it doesn't. What's wrong? Alright, I got that. We should pass encoded string to 0 path. Let's run the test cases again. Oh my god, what's wrong? Run the test cases again. Alright, all of the test cases are passed now. Our test passed. That's great, but our code is starting to look tedious. Sure. To be honest, we know how encode works because we built it, but someone else will have to spend just a little more time to carefully read the code in order to understand its intent. We can do better. We can refactor to a more declarative solution. Alright, let's do it. We can move this part to a new function. Alright, let's declare a private function and define a new function. Let's do the string. I'm gonna name this function to head because it gets the head of a string. It takes a string as its argument, void, and returns a string. And we can declare it as a constant function. Alright, move this part to this point. Alright, and also we can move this part to another function. We could name it to encoded digits. Sorry. It should also take strings as its input and return a string as its output. Move this part to this point. Alright. Now, at this point, we can use these two functions. I think you could call head function and pass the void to it, and then we can concat it to encoded digits output. Pass the void to encoded digits function, and finally we can move these expressions to this point. Alright, now this expression is more straightforward and is more readable, isn't it? Alright, structuring code in this declarative manner makes code considerably easier to understand. Actually, separating interface from implementation is an important aspect of design. You want to consider similar restructuring every time you hit the refactoring step in TDD. Some of you may be concerned about a few things in our implementation details. Maybe you ask me, shouldn't we use a string stream instead of concatenating a string? Maybe you ask me, why not use an individual char where possible? For example, why not replace return type to char, and why not replace this substr function with front function? Yes, we could do this kind of stuff. And maybe you ask me, wouldn't it perform better to use return std string instead of return empty character at this point? I mean this. Alright, we could do. Let's run test cases again to make sure all of the test cases are passed. Alright. We can do this kind of stuff. These code alternatives might all perform better, but they all represent premature optimization. More important now is a good design with consistent interfaces and expressive code. Once we finish implementation correct, with a solid design, we might or might not consider optimizing performance. We can refactor more. Alright. What should we do right now? I think there is a code smell here at this point, don't you think? We can eliminate the code smell of using a magic literal or hard-coded literal. Alright, let's replace it with a appropriately named constant. We could declare a const member variable max code length and initialize it to 4. We can replace this magic literal with that constant variable. Alright. What about the hard-coded string number 1 in this function? Actually, our code needs to translate the letter 1, the letter B to the digit 1. So we can't eliminate it using a variable. We could introduce another constant, or we could return the literal from a function whose name explains its meaning. Also, we could even leave the hard-coded string number 1, I mean this string, in place to be driven out by the next test. But can we guarantee we'll write that test before integrating code? Alright, we couldn't. Let's fix the problem right now. We can declare another function which is called encoded digit. And here we can return this constant variable, and we can call this function at this point. Alright, we are done. Let's run test cases again. Alright, what's wrong? It's failed. Sorry, we should return this variable. Let's run test cases again. Alright, all of the test cases are passed. Okay, that's all we have time for this video. In the next video, we will try to complete the Soundex algorithm implementation through TDD. I hope you enjoyed it. Thanks for watching us. See you soon.